Good morning, class. This is Bryan McCoskey, and I'm here to show off my final product for this class. Basically, creating a game, Unreal, and utilizing C++. Bottom line up front, I learned a lot, especially with C++. Given more time in my frenetic schedule at home, I could probably do everything in this game that you see in here straight off of C++. However, um, I don't have a lot of time in my spare time. So I've done the bare minimum with C++, and then a lot of the extra stuff you'll see in this game is used by Blueprints, but I have combined them both. This is based off of all the tutorials. So I'm going to go first by just reading off the syllabus and going off of that. And just know that I have, when I turn this in, I have all the CPP files that has all this as well written down on the code. But I just wanted to talk it through for as far as this narrated cast. So first off, display the character, which is one of the things we first did was create a character with CPP, and then display it, and then talk about how it moves. Here's our character. There's my overheated gun. That doesn't stay that way; it just starts out that way. So if I look at my C++ classes, and then I have my first-person character, and then that is located right here. Basically, what you do is when you create this, a lot of this code is created automatically. But just to go into the code, and then I can talk about it, right? It talks about comment your code to how explained your character is being projected. Well, first off, it goes through the inputs, okay? And under the actual the game engine setting is where you adjust your inputs. But other than that, it's right here. So here's where we talk about the inputs. And it talks about the different functions. Right here, here's your function. So move forward, add your movement input, get your forward vector. All right. There, add your movement input to turn right, move right, to turn at rate, look up at rate. All right. And what's crazy so about move forward and your move right. So essentially, you don't need the move forward and move backwards and a move right and move left, because your forward is positive and your backwards is negative. And the same with right. Your right is positive and your left would be negative. So that's what this tells, right? So it based off of the inputs. And so since I'm using keyboard inputs, right? So those inputs are either +1 or -1. +1 or -1. If it was a joystick or maybe even a mouse, you can make it full. You can go more so as far as floats. But for this is even though this says float, it's basically and it's tracked as a float. It's basically an integer style movement. -1, +1, and then or 0, meaning you're not doing anything. And then here's your turn at rate. Now this is where it talks about. This is where it goes. Specifically with floats, and you look up at rates, and that talks about your add controller pitch and add controller raw. So that's going to use your mouse inputs right here. So that's basically how it works. Is it takes your inputs right here and then it moves forward this vector. And I talk about, so a vector is a line in a specific direction in three-dimensional space. Okay, now this line as a vector contains your direction, right? So so you have your start point, your end point, x, y, and z. Your end point, both x, y, and z. But it's got your direction, your distance, right? Because there's a start point and an end point, so it'll have your distance. And then you'll also have speed values when it comes to a vector. That way you can control how fast it's moving. And then that's the physics part of it, right? So moves forward a vector, moves backwards a vector. And that's how it works. So this character, when you create it, you go and then you can go into project settings. And then once I get project settings here, I can go under inputs, and then this is where we deal with our input. Now, like we were talking about, where is bindings, action, movement, axis mapping. So there's your movement, right? So your move right. See, like I was talking about, it's either 1 or -1. Here it is, 1 or -1. All right. And then your lookup rate, and then your turn rate. That's using your gamepad. So your scale is 1, and then but it's from the scale, up to 1. So up to +1, up to -1, and that's more like they're all floats, but this one will go all throughout. So you can press right on your joystick really, really hard, and it'll go +1, or you can press right, sort of, and then it's like +0.5, right? So that's how that works. That's how that moves using code and physics. So moving down to the next one, camera system, right? So one of our second modules, we created a camera system. And you have a camera system that automatically plugs into this game. That's right here when you create your character. And this is a perspective camera. It's perspective because things that are closer to the character look bigger, and things that are further away look smaller. And it creates and simulates a three-dimensional view. And then it moves and changes by a little bit of a different ray casting. Ray casting. So it affects it, and like as you can see, as I move the camera, it changes the view, that sort of thing. And then on this one, we created a second camera. And what I did for this game is I wanted to create kind of like if you've ever remember playing, I think of Mario Kart, where in the very beginning when you play Mario Kart level, it starts up high, and then the camera, blends into the camera right behind you. And that's what we did in the tutorial. Is we created two different cameras, and this camera up here, and as you can see, it starts up high, and then it goes all the way down, and then seamlessly moves to here, gets behind this guy, and then it begins your game, which I think is kind of neat. I've never done that in Unreal before, and I think that's kind of a neat concept. How the cameras work, I talked about perspective. Well, you also have the orthographic, right? So if you want to talk about an orthographic pick, now the difference between perspective and orthographic is orthographic leaves everything, it doesn't care about the distance, it makes everything look the same, and essentially makes it look two-dimensional. And in fact, a lot of two-dimensional games use orthographic. They can use perspective as well, which kind of adds like a neat little flair to it. That wasn't around back when you played like the NES and SNES, that sort of stuff. But for the most part, they have like an orthographic view. And as you can see with the orthographic view, and then like let's say if I hit play on this, right? So if I play, it moves down to the camera, and then all of a sudden orthographic. It's really weird, and you can't really play a three-dimensional game with an orthographic camera. It's specifically built normally for three-dimensional games. But that's how this game simulates, and that's how it works. Other things you can do with the cameras in games here, which is kind of neat, is you can create another camera that's like attached to your character, and then make it have use a UI or a HUD, and then have that camera project on that HUD, and you can use it like a mini map. I've seen that done before. That's kind of neat. There's all sorts of stuff, and then plus, or you can have like, let's say you see this gun, and then the section behind the gun. Here, I don't understand why that gun is like that. I'm going to switch back. Let's go back to gun. Yeah, so I don't like. See, the material is FP gun, so I don't know why. Anyway, should be that. I don't know why it just stays at that state. It doesn't look like that when you play it, but when you start the game, right? Boom, there it is. And I've seen cameras that are like, you see where that scope is on the base of that gun. You could have a camera that shows the video of that part of the gun. So I think there's two pieces to the gun. So this is the gun that you see, and then I think there's another gun. Maybe it's the VR gun. Yeah, there it is. All right, so So I'm going to go back to the normal gun, if I can find it. FP gun, boom. There we go. All right, so now that looks like a gun. So that's your virtual reality gun, and for some reason, this is the gun that ends up being used when you actually play the game. So that's how that works. Next, collision detection. Well, we have a lot of collision detection in this game. Specifically for the point for C++, I've got C++ coded where the collision is based whenever I hit the lava. You see this collision box right here. Whenever that lava gets hit, it applies damage. I've got coded, one of my favorite pieces of code is right here. This was based off the light switch trigger. And as you can see, it's much bigger because in the code I changed it from a sphere to a block. And then instead of a point light, I made it the skylight, which works for this game. However, lighting is something I'm not very good at, and I'm still learning lighting. And this is just like a trick for the game. And normally I would want to find some way to for it not to affect that light specifically, because of the way this is, I can only have one of these in the game, because you can only have one spot skylight in the game at a time. Whereas if I wanted to do something right here elsewhere, that, like if I wanted to put it in this room, I couldn't do that because I can only have one skylight. But however, once the collision, based off my collision box, which is right here, once I collide with that box, it shuts this skylight off, which is neat, right? So that turns the light completely off for this room, which is a little bit of a maze. And it's also a little bit of, as you can see, kind of like a reflective type maze. So that's kind of neat. So if I show you how it works in here, if I go into this room, right, which he's doing anyway, I'm following this guy, but once I cross this threshold, boom, the lights turn off. And then it completely changes how this game works. It's kind of neat, right? So everything shuts off. And then I got to turn that debug piece off. But everything else, it makes for an interesting piece. And then when see, I'm in a maze. There's a bad guy going. Dude, I'm supposed to escort. And when I leave the room, I'm leaving the room. And there's the other room to go. But once I leave, bam, the lights come back on. Now, again, I talked about how I'm not still learning lighting. Because I'm not so great at lighting. A skylight, I don't quite know how to get to work in an enclosed area. So you can't see it here. However, when you turn the game on, you can see it. I actually have a roof on here. So this, I just have it, if you look at it right now, just for purposes of this, I have it invisible. Right now, the roof is up there. See, right? So the roof is normally up there, and I have the roof made of reflective material. The reason why it's made out of reflective material is I've turned off the ability to cast shadows, and so light doesn't interact with it at all. And so I just put a reflective material on it, so one, it kind of gives a neat little effect, and two, it's sort of cheating, because if I didn't have the reflective material, it wouldn't, it'd just be a dark whatever it is, because it wouldn't reflect light at all. So I just made it reflective, which kind of adds like a little bit of neatness. But just for this purpose, I have it, at least while in the editor, I have it off so I can see what's going on here. But yeah, so I'm still learning the light. But I do kind of like the fact that, so this collision, right? And as I talk about it in the light switch trigger, right? So what the collision does is it has a thing called on overlap begin. And what that means is when either your character or whatever you specify, so the object, which is the light trigger, has its own boundaries, right? So it's basically a cube, so it's got its own boundaries in 3D space. And then the mathematics of it basically checks either the collision box of my character or whatever it is I specifically tell it. In this case, I do specifically tell it the character, because if you look down, it's a specific actor. whenever that specific actor crosses within the bound box, that basically turns a Boolean on to true. And then once that Boolean on is true, then it performs other actions. In this case, it shuts this off. And then when I leave, it turns it back on, right? So if I look at this, I'm the light switch trigger, and then yeah. So and it talks about if I talk about specific actor right here. See, the specific actor is the first person character, which is located in this game. So whenever this and only this crosses into it. So I based off the original, I had to adjust the original code because the way the original code was just on any component overlap. And when any component overlap would approach it, it would turn on and off. So that means all these little muffins that get spawned in this game would turn it on and off. And so it'd just be like having a strobe light, which was kind of cool, but it really wasn't doing anything that I wanted to do. So I had to change the code to where it was specifically and an actor, and it's this specific actor, this specific first-person character. Only when this guy crosses in and out, he works. And because it turns dark, right, I got to add a really neat little spotlight to him. And so now he's got a flashlight, which works in the dark. And then with everything reflective, it adds a bunch of neat effects. And I kind of like it. Now, as far as collision-based things in a three-dimensional, not three-dimensional, but in a blueprint-style world, I created my medkit spawners. Now, I created the medkit in C++ before, but the problem with it in C++ is it didn't have a mesh, it didn't have material, didn't have anything. And so what I did was, so I can adjust it much easier. Well, I mean, I could have taken this and created I could have created my own variables and put it out right here. But what I did instead was I just created it. I right-clicked this, and then I created a blueprint class based off of medkit. So I created the blueprint class based off of medkit, and then I created my medkit. So this my medkit now, when you look at it, it's got its own box. Collision, it's got its own collision box. It's got its own static mesh, and I just kept it a simple sphere, and then it's a simple red sphere. So that's a health globe, right? And what I like about this now is I created a second blueprint called medkit spawner. Now medkit spawner also uses a collision. So if you look at your viewports, this medkit spawner has the source piece right here, your default scene root, but now it also has a collision box. And so what this collision box does is when so on event play, what this does is it does the spawn kit, right? So it'll spawn my medkit. So spawn your medkit. It will check if the medkit is occupied, right? So which the occupied is automatically false. The Boolean is false. And then once it's false, it will spawn the actor my medkit right here in the location where this medkit is. And then once it spawns it, it sets that specific spawned kit its own variable, which is right here, which is important. I realized instead of using get all actors a class, what this does is it actually specifies a specific object variable, and whichever one spawns gets its own variable, which is very important because since I have multiple kits being spawned, this allows me to despawn and respawn the specific one I'm looking for. So now that it is occupied, it's spawned. Now what this also does is now this checks on overlap, right? So once it's overlap, meaning once something's located within this box, specifically the spawn kit right here that I set right here, once it's specifically overlapped with this and that condition is true, it will set my Boolean as is occupied. Okay, So since it's set as is occupied, it's good. And then if for some reason, like since it's true, it does nothing. It just sits there. Now, once this thing gets picked up and the end overlap happens, again with the same spawn kit, once that is true, it sets that occupied as false, waits 5 seconds, and then runs the spawn kit custom event again, which basically spawns another actor. So it's an example of in a blueprint version of using the on component begin overlap as opposed to the light switch trigger right here, which is on overlap begin with this specific actor, right? So it's another way of showing the same thing. So that on this one, what it does is whenever it overlaps my specific actor, it toggles the light, right? And what toggle light does is it toggles visibility, all right? And then once it ends, it toggles light again, right? So it's just another way of doing it. But what's kind of neat with this, right, is so I have it right here. This is your health. And then I have it, these visible just so I could have seen when I was debugging, I can see where it goes. But let's say I get hurt, right? I'm getting hurt, right? And then I run this off. It heals me, see the 80%. And then after 5 seconds, it shows back up again. So I can technically keep on healing myself every 5 seconds, which I kind of like. And then what I like about it is now we're going to, let's say if I put in another medkit spawner right here. Because it gets the because of the, it sets its own variable, right? Once I get hurt, see they're both here. If I get hurt, let's say, like, thanks a lot for hurting me. I take this one, now I'm back up to 100%. And then after 5 seconds, they both spawn, which is great. So like I said here, boom, 100%, and then they both spawn back up. So let's get rid of that. So that's how I worked my collision piece. I mean, other collisions within the game. There's a collision code that when my enemy muffin collides with you, it applies damage, which affects both him and myself. Other collision, like I said, I already showed you C++, the collision here, and then the collision with this. I guess the other collision is my paintballs, which I created in the very beginning. Is on colliding with anything, it deletes the vector. It deletes what is it called? Not stickers. What are these called? Mats. Paint splat material, paint splat texture, and then if I actually go to first person CPP blueprint, first person projectile, decal, so it spawns decals, which is the paintball, so it makes it look like I'm shooting a paintball, which I kind of like. So that's it destroys itself and on the place, so that's kind of neat as well. So as far as collision, that's where we got. And then next is follow path. In reference to this follow path, the key that you need to do is have a nav mesh. And what a nav mesh does is it is a boundary box that automatically contains algorithms to move for a controller, an AI controller of some kind. So if I hit P, this shows me where the navigational box is. Now, this is because the top is invisible, but if I look down, here we go. So within here, this is where any of my guys will move, right? So you'll see where the green is, and then this affects where my dude or the enemies will actually move because they both use the bound boxes. Move within the where it moves within the maze. Boom. So let's get rid of the boundary box. But what nav mesh does, like I said, is it automatically contains the algorithms to move from a point to point. And you can actually go into the nav mesh in the settings and within the game editor, if I can find it, nav mesh, boom. And you can adjust settings. So you can adjust the different settings of the nav mesh in order to figure out exactly how it works. But what this does, what this AI controller does, is now when you have, for example, this muffin who's got the controlled, it's actually movement by the whatever pawn is. So AI controller, tag controller right here. So under pawn, and I use controller, AI controller, and then this, different settings you can use to adjust it. So this talks about your different rotations. If you wanted to look toward, this actually has your yaw, so it's looking towards what direction it's going. You can have a yaw, roll, and pitch moving towards the direction you want it to go. And you can adjust the settings that way. And then what this does is if I go into my my C++ for my controller, what this does is right here, it gets all actors of class, so it gets all waypoints within the game. Or I'm sorry, gets all target points within the game and sets them as waypoints. All right, I have 4 target points within the game. It gets them all and then sets them at waypoints. And then it selects one at random. So this is on range between 0 and the waypoint -1, because that's how item lists work within coding, 0 to 1 minus it. And that creates your random number. And then it'll select that waypoint at random, and that becomes the new waypoint. And then it what's so great about nav mesh is instead of creating an algorithm that says, after X amount, raycast this way. If you see a wall, then move over to the right. If you see a wall, keep moving to the right. It already contains that algorithm in there. So all you have to do is write this code right here. It's move to actor random waypoint, which is the random target point, and that's it. So, and then it automatically uses the algorithm in it to move to it as efficiently as possible. Whether or not that's realistic, I mean, it depends on what your nav mesh bounds and settings are. This is just the basic settings, so it's not that great of movement, but it does move where I want it to go. And then on movement complete, it will wait a second and then move to a different random waypoint, and that's how the controller works on here, and that's how it uses a nav mesh within the game to move. I created a blueprint version of the nav mesh right here with these guys. These guys are real simple. I wanted to create just another room that had like some sort of obstacles. So I created. Oh goodness, where is it? I just created a simple blueprint, which is a mover. And what this does is it uses your basic controller. And what it does is it sets its initial location, which is where it's located. And then it takes its initial location, leaves Z alone, right? Because it's not going up and down. And then from a random set between -500 and -500, -500 and -500, adjust the X, adjust the Y, and then that creates this new vector. Then it sets the new location with that vector, and then at a specific delay time, which is from anywhere from 2 to 10 seconds, it'll wait, and then once it waits, it'll move. It'll move itself to that location, and then it'll, on completion, it'll do that again and hit a retriggable delay, and it just becomes a loop, right? And so what these end up doing is when I go into this room, it just provides, which is where he's going anyway, you just see all these things moving in different directions, causing chaos. I can make these bigger, I can make it smaller, it's just like I gotta move around them, which kind of adds a little bit of, which is kind of neat, I guess. Just something different, but that's It was a blueprint version of using using the controller. So now I've got both C plus and blueprint. And it's something that I've learned actually in this is just how easy it is to work with both. And I assume that's how they make their, for example, that Fortnite is this game. And I'm positive that certain things they use blueprints for, and then a lot of things they probably just use they just use C++, and then C++ is more specific, and but it's more technical, harder to do. So here we go. We take it, turn this on. I really like this. I like it becoming dark. Anyway, so using blueprints and C++ becomes pretty seamless with this. I kind of like that. And then finally, the user interface. So the user interface that we created, which is your damage HUD. What this damage HUD does is it creates this widget and adds it to viewport. And that's really all this does. And it's a real simple it's a real simple code that just adds this to your viewpoint right here. So whenever you play, it adds it to the viewport, and then that's it. However, I've created 3 different HUDs for this game. The first HUD that I created basically did what this does on C++, and then this one took over for it. So I just kept it. And so the second one, the first one that I created used to do the health, and then I've deleted that. But it also keeps score for the game. And then this one here keeps the health. It keeps track of the health of my character and the escorted character. And then finally, I have the end game HUD. Now, something that this game does is that I had to delete from the code and then just do it straight from blueprints, was when I look at my character and oh no, when I go to the where is this at? It's at the game mode CPP. So when you look at game mode CPP, what it does is it basically checks all the time for your player's health. And what it was doing is whenever I ran out of health, it would do the game over thing. It would do the game over and reset the level automatically. And what I want it to do is use. I like this, and what would be neat is if I could use this to create my game over HUD to display. But I was struggling with it to work on C++. So I ended up using it just in Blueprint. So I've deleted this. I didn't delete it. I coded it. I commented it out. It shows it doesn't do anything now. And now what ends up happening is on Blueprints, I do have it do the same thing. So if you look at your open level blueprint, I don't even use it the level blueprint. I want to say, yeah, I don't use it on the level blueprint. I use it on the first person character blueprint. So on the first person character blueprint, I created event tick. So right here, here it is. So it did the same thing that did, right? So on the event tick, and what I thought it was kind of neat is this right here, get health, is actually a C++ variable. And because if you look at my player character right here, and I actually need to go to H. So if you look at where health is, down here, if you look at health, it talks about edit anywhere, blueprint, read, and write. And then that's the health one. And because it's blueprint, read, and write, and it's edit anywhere, I can change it within my blueprints. Now, I'm not changing it, but all I'm doing is receiving it. So at event tick, I'm checking my health. Is anytime it gets below and equal to 0, it activates the player death. And what player death custom event does is it actually puts over the game over widget as well. Once it puts over the game over widget, it basically puts this control mouse back up instead of controlling the game, and then it sets the game paused. And then when this game over widget right here that I created, all right, so the game over widget, right here. It's game over. This shows your final score, and this is your play again button. So if you go into your graph on this button, so basically what it does is on clicked, it unpauses the game, and then it basically reopens the game. So what this widget did is it does what this code did right here. So it does the same thing. Only I couldn't get it to show up on this. So using this, I was struggling, so I just left it with C++. I've already done it with this one. I was just really struggling to get it to work on this one. So that's something I clearly need to work on. So I believe I am done talking about all the stuff for the final. And again, like I said, I have all this stuff written down in, like for example, if you look at it, I have all this stuff written down in the code, which will be submitted with the final. I just wanted to talk about it in this video. So without further ado, I've talked about a lot of the new stuff. I am going to play the game and show you what the final game looks like. Like I said, it's a real simple layout. This is where you begin. I've got 2 levels with simple simple obstacles, like river. I guess this is like a river of lava, right? And then this is a lava pool right here. This lava will injure yourself and the escort. So the object of the game is to just escort this guy around as he moves to the different waypoints in the game. So we have 4 waypoints in the game. There's 1 in each corner, and he'll move to different waypoints, and then he will pick another waypoint at random and move to that one. All right, and then while that happens, enemy muffins will spawn, and they will either chase him or they will chase you. If they ever touch him or you, they apply damage. You have the ability to shoot them, and as of right now, for balance purposes, I just have 1 shot and they die. And then you can only shoot basically 5 rounds at a time without doing the reload. Now I have it on an automatic reload. I don't have a reload button. That'd be something I could probably add to this game for later on, is maybe like a reload button that does it for you. So that is that's the gist of the game. Like I said, I've got obstacles here in this room, and then I have obstacle here in this room, which is just the lava pool. In this one, nothing hurts you. However, these move around, and then they just get in your way, which is kind of neat, right? I think, because these just all move in random directions. This is the super fun room. I created a basic maze, which to get to. And whenever you walk into this room, it turns the lights off for the entire game, which I kind of like a lot. And each room has a health globe. The object of the game is to just go as long as you can until either you are killed or this guy is killed. So without further ado, let's play the game. So there we go. As you can see, like I said, I just made it reflective, which kind of adds to it. He's going into the room where everything's moving. So everything's moving. So here's get bad guys as they spawn. Now, as you'll notice in the bottom right, my score goes up every time I kill them. So he's moving to this random waypoint, which is fine. So the longer you... Oh, I didn't even see that guy. So the longer you're in the game, the more of these guys are going to show up, because they spawn every 3 seconds. So he moved. Now he's moving to a different one. And we got more. In the bottom left, you'll see on yellow my ammo as it goes down. So like if I shoot them all real fast, I run out of ammo, and then I can't do anything. I have to wait for it to reload. It's right there. So here's the game. It's just moving. All right. These guys keep spawning, and then they're coming to get me. I'm out of ammo. Physics works. These things move. That's kind of neat. All right, I'm not hurting. But what I can do is I can, oh look, I got hurt, and then oh look, I got life. And then when this thing shows up in 5 seconds, all right, I healed myself. All right, so here these guys are coming after me, and then oh no, so this guy hurt him, and then now we're there's another one. So this part is where a lot of stuff goes to die, right? So you can't see anything. I can't see, and I don't know which way I'm going specifically because I am in a maze. enemies. So he moved to the waypoint. Now he's going to go to. So, God, it just gets crazy. I'm out of ammo. See, there comes a point in time where you just can't. You just get overloaded. All right, there we go. Game over. Final score 29. Game ended. So that's the game. I'll play one more time. Maybe he'll go in a different direction, so I'll play it again. Boom. And now we're going this way into the... oh, no. I'm going to go to the waypoint over here. Now, stuff I could probably do to change how the game works, right? So instead of having them both being spawned on a target point, and like what the enemies being spawned at a target point, and, the waypoints being a target point, I would change the spawner into like a an actual. I would create an actual spawn instead of a target point. Well, kind of how I did the kits. Only I would do that instead of using, and then that way they're not spawning. They're spawning in different places where he's going, instead of spawning in the same area that he's going. And then of course balancing out, find the really good balance between how often I can shoot and whether or not it affects what happens. So like as right now I can only shoot like once every few seconds, and then it's gotta wait. And then I would also add like a see right there, he just showed up right where this guy was, and so there's nothing you can do about that, right? There's no fun in that game. I would add the ability to reload. That way, if I'm not doing anything, I can reload. Oh my goodness. And then maybe find like a grenade or something that destroys everything in the. See, I can't do anything. Boo! Final score 29. I would get like a grenade, or maybe something I can heal the guy I'm being escorted, right? Because for right now I can heal myself, but I can't heal the guy that's escorted. So there's a lot of different ways I can adjust it and make it better. Of course, you could always adjust it graphically, and make it look much better. But this is just this is just a concept, proof of concept. I don't even think it's a prototype, but it's just a quick proof of concept of my first time creating a game with some C++ elements, which is kind of neat. I can make these bigger so they'd actually push you out of the way. I don't know. Just different things you can do to change this game. But I like it. I learned a lot in this class, and thank you so much.